ના.
હવે
નથી દેખાતું.
ના.
અચ્છા. મારામાં ફૂલ સ્ક્રીન જ બતાવે છે. 1 મિનિટ સર, કદાચ એટલે એકચ્યુઅલી છે ને ચાલુ થશે ને પછી એ થઈ જશે. મારામાં એવું થાય છે ઘણીવાર.
Okay. Good evening, participants, and welcome to ATAL FDP on rainwater harvesting for sustainable groundwater development. Today, we have Dr. Namrata Jariwala, Assistant Professor, SVNIT Surat, as an expert. I request Ayushi Panchal to introduce Dr. Namrata Jariwala, please.
Yes, sir. Good evening, everyone. Dr. Namrata Jariwala is working as Assistant Professor in Department of Civil Engineering at SVNIT Surat. She is having 20 years of teaching experience. She has published 25 papers in peer-reviewed journals and has guided 3 PhD students and 21 MTech students. She has wide experience of development of laboratories in the field of environmental engineering. She has handled various consultancy projects of SMC and other local government bodies in the area of water and wastewater treatment as well as solid waste management. She is working in research area of health and risk studies of environmental engineering, air pollution related studies, soft computing techniques in environmental engineering, and fuzzy logic with applications. We are very pleased to have Dr. Namrata Jariwala as our today's speaker. Now I invite Dr. Namrata ma'am to deliver her talk. Over to you, ma'am. Thank you.
Now it is full screen.
No, ma'am.
Okay. Now is okay.
No, ma'am. I think you stop presenting and present again.
Okay. Now it's okay, sir. Sir, now is okay.
Ma'am, try to make it PPT mode. PPT mode.
Good evening, everyone. I think now is okay, sir.
It's not, ma'am, but we'll do. Continue. No problem.
Okay. So good evening, all. I am presenting here impact of point and non-point pollution sources on river water quality with a case study of Tapi River. So as we all know, when we talk about the impact of a point and non-point source, so we have to consider two important things. We have to consider the surface water source and we have to consider the groundwater source. Now, as far as my talk is concerned, mainly I am dealing with a surface water source. Actually, I'm not discussing the groundwater source here. Now, if we start and we have discussed from last 3 days, our Indian Sanskruti, it's considered to be a cultural water heritage Sanskruti, and generally we all love water, and actually everybody in the world whatever the Sanskriti we consider, so Egyptian and all, so they all love the water. And generally the urbanizations before that, whatever the Sanskriti we consider, so we have started living on the bank of the river. Coming to that, we have a right now modern world cities, but in that we have to think a lot regarding the water management. Earlier we don't have to think for the, when we were having the Sanskriti, so earlier we don't have to think for the water management, because only there were two words, water and wastewater. There was no words like a pollution, and that is why they don't have to think for, they were not thinking for water management, because everything was available and everything whatever they were utilizing, so ultimately whatever the wastewater they were generating, so ultimately it was taken care. But as we have shifted towards the modern cities, we have to think for the water management and water planning, so which is a main crucial job of our civil engineers right now. So this is a very important thing that all over the world we know that the availability of the water is very limited, and at the same time in the utility we have a more and more water for utilizations. We require more and more water for the utilizations, and that is why generally our utility side will be always on a higher side, and compared to that availability will be on a lower side. So there is a we don't have a proper balance between availability of the water and the utility of the water. When we talk about the world, so right now we have the world is facing the problem with the three important criteria. There are some of the reasons in the world where we have a the water is not available, as we have discussed in the FDP, the scarcity of the water. There are some of the reasons where the water is available, but the quality of the water is a questionable. And the third, that is nothing but the availability of the water. It may be possible that the reason may be having a nearby water source, but when we consider right now the community level, community participations and the community, the water availability at the tap, so that is not available. Now, we know that the water quality is not good. So we may have a lot of ideas. We may go with the recycling, reuse. But the very important thing is, we all know that 70% of our human body that contains the water. So the body which needs the water, that requires the fresh water. So if you just see our all the part of the body, so the major very important part of our body or the organ of the body, so that requires a lot of quantity of the water. So for these, definitely.
Excuse me, ma'am.
Sir.
Ma'am, have you changed the slide, because we are seeing the first slide only?
Sir. 1 minute. I think, sir, presentation.
Yeah. Now it has changed.
Is it okay?
Slide has changed now. You change again. Change next slide.
Yes.
No, it is not changing, ma'am.
Now?
No, it's not changing. Now it is changing. Change again. Next. Now it is changing.
Okay. Now is okay, na?
Yes, it is okay.
Okay. So when we consider the water management, so for this, if we just consider the scenario of India, so in India we have a major 14 rivers, river basins, and we may have a lot of minor rivers, and there are some several tributaries of that. Right now we all know that there are so many rivers, but these particular rivers are nothing but it is a polluted rivers. It is like a drain. And this is because of the sewage and the industrial waste of the discharge. So the very important thing is, when we use the water, we are generating the wastewater, and these wastewater nowadays we require to treat it, and for that hardly 10 to 20% of the particularly the wastewater whatever is generated, for that the treatment is available. Otherwise, the majority of the wastewater whatever is generated, without the treatment, it is entering into the water bodies. Definitely we have right now the government is taking so much initiatives, and because of that this particular figure is particularly will change, because in a JNURM projects and all, a lot of financial support is given to the Tier 1 and Tier 2 city for the constructions of the STP and the water and the wastewater treatment plant is concerned. So if you just see the scenario of India, so majority of the Indian cities where you can see the blue lines. So this blue lines is nothing but it is the wastewater generations, and the red line is nothing but it is the wastewater which is treated actually. So you can see there is a gap between the treated water and the whatever the wastewater we are generating. And that is why the developing nations, we are having the similar scenario. And in India, majority of the particularly in the majority of the part we are facing the problem as far as the quality of the water is concerned. Now why we talk about this, and why we require to consider the quality of the water as far as the urban cities are concerned. So before that, we know that the very important thing is when we consider the water sources. So there are two important sources that we are considering. One is a surface water and second one is a groundwater. So there are common issues like whatever the microorganisms and the pathogens we are considering, the salinity issue and the toxicity. There are some of the micropollutants which are responsible for the degradations of the organic matter, and at the same time they are toxic. So for surface water and groundwater, these are the common issues. But as far as the surface water source is concerned, so right now we are mainly facing problem of the eutrophications, oxygen depletions, and the ecological health of the water bodies. Whereas in the groundwater, because we have discussed this, the groundwater where the geology and everything is coming in the picture, and because of that there are so many areas in India where we have a fluoride problem, we have a nitrate problem, arsenic problem, and the seawater intrusions problem. Now, these are the problem, but anyhow, we require the water for the drinking purpose. So mainly I'm concerning the quality of the water with respect to the drinking purpose. Now, this is a very important figure. As I have discussed, when we are considering the cities and cities are generating the wastewater, and for that wastewater, we have a generally treatment plant. We consider that each and every city, at least the STP is available. And if we are having a STP, then how it is having again a burden to the water source. So you can see in this particular figure, you can see the river water. And from, I think you all know, as from the river, we are getting the water with the help of the intake well. And generally, that from the intake well, whatever the water is available, generally we treat it in urban areas. So generally in urban areas, the water treatment plants are available. We treat that particular water. Generally, then we store that particular water in an elevated storage tank, so that we can, without a pumping, we can distribute the water very effectively in a complete community. Now, from this particular community, we are generating the wastewater, and this wastewater, again, it will be collected in our drainage network. And from this drainage network, it will be coming to the wastewater treatment plant, or you can say the secondary treatment plant. So generally, we have a criteria, you all know, as we have to maintain BOD 30 milligram per liter, COD 100 milligram per liter. So whatever the water is treated, so that treated wastewater, again, we are diverting into the water bodies. So this is a very important cycle, and that is why in urban areas, we have to be very, very careful as far as the water sources are concerned and the management of the wastewater is concerned. So if we are not managing our wastewater treatment plant effectively, then ultimately we are giving a burden to our water bodies. And this burden, because of this burden, ultimately we are giving a burden to our water treatment plant. So the very important thing is, when our water treatment plants, if they are not able to remove some of the impurities for which they are designed, so ultimately the people or the community, they will not get the good quality of the drinking water. So if you are not getting a water for other purpose, good, not good, then okay. But for a drinking, at least we require a very good quality of the water. Drinkable purpose water, it should be available. So ultimately, we require to manage and the balance between the water treatment plant and the wastewater treatment plant. And if we are ultimately, your one side is on a higher side, then definitely it will give a complete loopholes in this particular cycle. And majority of the Indian cities, we are having this particular problem. So The very important thing is developing nations, our wastewater treatment plants are only designed for the primary and the secondary treatment. So nowadays we have to think for the tertiary treatment also. But developing nations, always we are having a financial constraints. And when we go for the tertiary treatment, definitely we require a lot of financial support. And that is why generally we are avoiding the tertiary treatment. And because of that, what is happening? When we are requiring tertiary treatment, so tertiary treatment is mainly for the removal of the nutrients. Primary and the secondary treatment is for the removal of the organic matter, and tertiary treatment is for the nutrient removal. So when we are not thinking for the nutrient removal, so ultimately the nutrient are remain as it is into this particular system, and ultimately that we are discharging into the water bodies. And because of this, what is happening? Ultimately, our water bodies are becoming the very good source of the nutrients, and because of that, we have a eutrophications problem. Once you have a eutrophications problem, these eutrophications will carry a load on your water treatment plant, because for nutrients, what you are not able to remove it in our wastewater treatment plant, it will remain as it is in your wastewater treatment system. So this is a very important strategy that we have to consider in our day-to-day nowadays, whatever the management we are considering. So if we are failing this, the day will come where we have to think for this. Otherwise, for the health hazards, we have to be ready with this. So the very important thing is we have to consider the balance between our water treatment and the wastewater treatment. And if we are not doing this, then ultimately we will be having a problem. Now, when we are considering the major problem as far as the water pollutions are concerned in streams and rivers, so as we know, this is extensively polluted. But the very important thing is, as I have discussed, the nutrients, because when we are considering the wastewater, whatever is generated from the particularly from the domestic unit, so it mainly contains the nutrients. It contains organic matter. So organic matter, for that our treatment plants are already designed to remove the organic matter. But primary and the secondary treatment cannot be effectively remove the nutrients, and because of that, majority of our water bodies right now, they are facing the problem of eutrophication. I think you all know eutrophication is nothing but the ultimately the excess algae growth. So the green particularly the green loans type of the material, the water aquatic plants will be available in a water bodies. So this is a very important thing, and for this, if you want to clean it up, then it will be a very, very difficult task. But instead of that, if you take some preventive measures and you are able to control it very effectively, then I think you are conserving your water bodies very, very effectively. So here prevention is very, very important, and for that we have to take some of the initiatives. And if we take some of the initiatives, then and then we are able to manage our water sources very, very effectively. We can consider our source that is to be a clean source for the water source. What is your, I think all we know, streams can cleanse themselves. Yes, definitely it can cleanse. Earlier, I think there was no water pollution problem, as I have discussed the ancient Sanskruti. So where we don't have, we were not having a water pollution problem because there was no overloading. Right now, we have already given a burden to our water bodies. So if man do not overload them, the natural resources, then definitely nature has given a self-purification capacity of the stream. I think those who are from civil engineering background, so they know the self-purification of the stream concept. The second very important thing is if the flow is not obstructed, your stream or the water bodies is always a flowing stream or the water bodies, then always there will be the velocity will be always available, and because of that also your stream will be considered to be a healthy water bodies. So if there is no overburden, and if the flow is always flowing, means there is no stagnant water, you can say, and then because of that there will be a natural biodegradation process, and because of that, if you are diverting the wastewater in this type of the water bodies, then also the naturally, slowly and silently your water body will clean up. And again you will get, so initially you may have a yellowish type of the water, but ultimately naturally it will clean, and then again you may have a bluish type of the water. So nature has this type of the capacity, nature has given this type of the self-purification capacity to the streams. But the very important thing is, we all know the anthropogenic activity, whatever is responsible, and because of that ultimately the streams are and the river water bodies are nothing but it is the drains. Now there are two important things. One is a contaminant and the pollutant. So when we are considering pollutants, so the contaminant is it's a broad word, and when we are considering the pollutants, so generally it is a site specific, and the contaminants, it's a particularly the broad. So you can say the pollutants are nothing but it is a subset of the contaminants. So when we consider the water pollution, so in a water pollution, generally there are two important things we have to consider. So the very important thing is that there may be some of the harmful organisms, or there may be some of the contaminated chemicals. And the third very important thing, generally we are not taking care of this, but the excessive heat or the temperature is again a very, very important factor as far as the water pollution is concerned. Why heat or the temperature? Because as the temperature is increasing, the dissolved oxygen will go down. And because of that, as the dissolved oxygen is going down, so ultimately the aquatic life and everything will be problematic. And because of that, ultimately we have to consider the heat, excessive or the excess temperature also a very important source. So as I have discussed the water pollution, so for that you may have a source like agriculture, industrial activity, and the mining. Now the very important thing is we have to consider the point source, and we have to consider the non-point source. So when we are considering the point source, generally it is located at the specific place, and it is very easy to identify, it is very easy to monitor, and it is very easy to regulate. So whenever we have urban cities, so in all the urban cities, generally the treated water or the partially treated or the not treated wastewater, we are directly diverting it to the water bodies. So generally the outlets are known source, and that is considered to be a point source. Now the non-point source, it is nothing but it is a diffuse areas, it is a broad areas, very, very difficult to identify and to control. And you want to clean it, again, it is very, very expensive process to clean up all the non-point source. So I think you might be knowing the cattle farm, whatever is available in particularly the urban areas. So generally जो हम लोग तबेला और ये बोलते हैं, तो generally it is nothing but it is the very important non-point source. Generally, as we are dealing in air pollution, generally in air pollutions we are dealing with the area source and the line source. But when we are dealing with the water pollution, generally we have only two type of the source. One is a non-point source and the point source. So you can see here, this is particularly the outlet. When we are diverting the treated water or the industrial wastewater into the water bodies, it is considered to be a point source. We may have a non-point source, and in non-point source, there are some of the areas from where you are getting the varieties of the varieties of the wastewater. Then generally the quality of the wastewater will be varied. So generally you may have a cattle farm, you may have a urban residential colonies, and from that you may get the directly discharge into the water bodies. So these are considered to be a non-point source. It's a very hard problem to solve. Non-point source to control, it is a very, very difficult task. Generally point source, you can manage it, and it is the duty of the urban authority to manage the point source very effectively. And nowadays, as per the guideline, no one city is discharging without the treatment the wastewater into the water bodies, and generally for that we have a stipulated guidelines. Dissolved oxygen to be maintained, BOD 30 milligram per liter and COD 100 milligram per liter to be maintained. But for a non-point source, it's a very, very difficult task. Now, when we are considering the point source characteristics, again, whatever the source we are considering. So in a point source, generally we have to consider the whatever is the input and whatever is the output. Only we have to consider two activity. There will be accumulations of the pollutants and there will be a decaying of the pollutants. So point source is very effective to control. Where we are considering the non-point source, you can see here you have a varieties of the source, and whatever is the source, ultimately the characteristics will be also varying. Suppose you may consider the agriculture as a non-point source. There may be agriculture farming activity nearby the field, whatever is available. So from that you may get the pesticides, you may get the nutrients, means the ammonical, nitrogen and phosphate concentration is very high. But if you have a construction activity, so from the construction activity, generally the suspended solids will be more. So the non-point source is already difficult to control, and at the same time you have to consider the varieties of the sources, and at the same time you have to consider the varieties of the characteristics of the wastewater at the same time. And that is why generally the non-point source is very, very difficult to identify and to control. Now, when we talk about the water pollutions, the stagnations of the water is a very, very important problem. Now, why we consider the water stagnations? Because in urban areas, we have a haphazard planning. And because of that, sometimes we are obstructing the natural water bodies, whatever is available. And because of that, the natural slope of the water bodies. And because of that, what is happening? The water will become the stagnant. There is no flow available. And generally in a summer season, this is the problem everywhere in India. So a majority of the perennial river, we are facing this particular problem. And this stagnant water will give rise to the malaria and dengue pathogens. So this is a very important thing, and the stagnations of the water is not good. I'm coming to that particular point again. Now, at the same time, we have to consider the thermal pollutions, and generally earlier we were not considering the thermal pollutions or the excessive temperature problem as far as the urban authorities were concerned, or the urban areas where the water bodies are there. But nowadays we have a varieties of the activity, and because of these varieties of the activity, we are considering the hot wastewater. So many garages are available. There are so many industrial activities are available. Laundries are available. Bakeries are available. And these are not having any particularly the treatment facility. These are the small scale industries. They are diverting their wastewater into the drain. And because of that, in a drain or sometimes directly into the water bodies. And because of that, the temperature of the water bodies, whatever we are considering, when they are diverting the wastewater, which is having a higher temperature, so that will deplete the dissolved oxygen available into the water bodies. And that is why we have to consider this, because when your DO is going down, ultimately that may be creating a problem of the, as far as the aquatic life is concerned. As DO going down and down, there will be anaerobic conditions that may create an odor problem. Now, the very important thing is how to measure the river water quality. So healthy streams, how to manage and how to measure. So the very important thing is the one parameter that we all know, and that is nothing but the dissolved oxygen. So generally, the fish is a very good indicator of this. So when you can see the fish in the water bodies, at least you can see 3 milligram per liter dissolved oxygen is available. So the very important thing is the dissolved oxygen is a very, very important test, or it is an indicators. And this DO, with this, you can have a range of tolerance. When you see the fish, you can see at least the DO is the enough quantity of the means. You can see the 3 milligram per liter dissolved oxygen is available. You can see in this particular figure, whenever towards the directions of the flow, we are discharging the wastewater. Now, when you are discharging the wastewater, at least you have to see that when there will be a mixing of the river water with the wastewater and the river water, it will mix. So at least after mixing, also 3 to 4 milligram per liter dissolved oxygen is available. It should be available. And for that, generally we have a criteria of BOD. So once you have, because if you are in a wastewater, you have a less organic matter, then the DO, whatever is available, it will not utilize. And for that, we have a limit of 30 milligram per liter as far as the Indian standards are concerned. So the one parameter, with the help of this, you can measure the healthy water bodies, and that is a DO, dissolved oxygen. Generally, you can see the DO with a color combination. So generally, when you have a greenish or the bluish water, so you can see the DO will be very, very high, 8 to 9 milligram per liter. And when you have the yellowish water, you can see the DO will be less than 4 milligram per liter. Generally, all our the water bodies and generally the sea coast, generally we do not have a this type of the green. Up to green is okay. Bluish water, the water or the beach is only available in a particular part of the world. In India, I think you can see the Andaman and Nicobar. So where in Andaman and Nicobar, you can see the DO, it will be very, very high, 8 to 10 milligram per liter or 8 to 10 ppm. So generally, the one parameter, that is a DO, and we generally first consider the DO as a very important parameter because DO is easy to measure. Even nowadays, the probes are available, and with the help of the probes also, you can measure like a pH meter, or like a temperature. Just we put it in the beaker, and you will get the reading. The second very important parameter is a BOD. BOD is nothing but the biochemical oxygen demand, as we all know. And generally for that, we have a limit, and that is a 30 milligram per liter. Generally, after the treatment, we have to see that the 30 milligram per liter in a wastewater, means the BOD of the wastewater, it should be 30 milligram per liter. Why 30? Because ultimately, when we are considering the 30 milligram per liter of wastewater, the wastewater BOD, so that we mix with the river water. So generally, the river water where you have a no organic matter, only the dissolved oxygen will be available. So ultimately, if it is mixed, so after mixing also, you may have a 3 to 4 milligram per liter. And generally for that, we just consider the river having BOD. So generally 5 to 10 milligram per liter. If the BOD of the river water is in this particular range, we can say the river is effective, means it is having a less pollution problem. Generally, this is a very important criteria. I'm coming to that. So ultimately, we have a guidelines as far as the CPCB is concerned. So Central Pollution Control Board has developed some of the guidelines as far as the healthy river water bodies are concerned. So for that, there are the various parameters they are considering. So based on that, the DO and BOD are the very, very important parameter. And generally, where the BOD is up to 1 to 10 milligram per liter, so that river is considered to be a good river. So it is considered to be a healthy river. So this is the classification of the Central Pollution Control Board. So the Central Pollution Control Board has initially in 1980 developed some of the guidelines, and with the help of that, they have categorized the Indian rivers into A, B, C, D, and E classification. And in that, they have considered two main parameters. One is a dissolved oxygen and BOD of the river. So if the dissolved oxygen, so generally it is between 4 to 6 milligram per liter, and BOD it is up to 10, maximum up to 5 milligram per liter. So that was considered, and based on that, they have considered the A, B, C, D, and E classification of the river. So generally, A classification of the river, where the river is where the quality of the river water is very, very good. And generally, it is considered to be a glaciers rivers only. Even the Ganga and Yamuna, when they are entering into the urban areas, they are not considered to be a glacier rivers. Glacier rivers, when they are, means from Jamnotri se jo nikalti hai, so at that time, generally it is considered into the A category of the river. So where the pollutions will be very, very low, or you can say there is no pollution. So according to that, only A category, Ganga and Yamuna. So when it is only in the Himalayan regions, so it is falling under this particular category. And generally, the majority of the Indian rivers, so generally, it is falling in D and E category in a particularly summer season. Yeah, during monsoon season, it may be in B and C category of the river. Now, the CPCB has also revised the criteria as the time passes. So generally, as we know, in urban areas, majority of the urban cities are depending upon the water bodies for collecting the water for the, as far as the drinking water is concerned. So generally, we are getting the water from the river water. River water is generally we utilize it for the drinking purpose. So generally, looking to that particular criteria, this A, B, C, D, and E category of the river classifications, they have strengthened again in 1982. So considering more parameters like a pH, DO, BOD, even the electrical conductivity, hardness. So based on these all parameters, because the slowly and silently what is happening, so whatever the wastewater was generated, so that wastewater without treatment or partially treated wastewater, we were diverting into the water bodies. So we were making our clean or the healthy river in a polluted river. And because of that, the criteria were strengthened again in 1982, and depending upon that, they have classified again the river into A, B, C, D, and E category of the river. And here there was a clear-cut guideline: if the river water, if it is coming under the category of the B and C, then and then that particular water you can utilize it for the drinking purpose, and also with treatment plant only. Without treatment plant, you cannot consider this particular water. So this was the classifications of the river, and that is based on the, because the varieties of the means because of the water pollutants increasing into the water bodies. So generally, because of that, the criteria were more strengthened. Right now we have A, B, C, D, and E category of the river. Again, it is for a specific purpose. So suppose if you want to use that particular water for the bathing purpose, then the criteria is different. You want to utilize it for the drinking purpose, the criteria is different. You want to utilize it for the fishery and the irrigation purpose, the criteria is different. So mainly based on the particularly the criteria, but here this is the classification which is adopted in 1990, and in that particular classifications, the pathogens or the microorganisms were given a due priority. In earlier two classifications, microorganisms were not given a priorities. So you can see here in this particular slides where the total coliforms we are considering. Now, this is the particularly the classifications where we are considering the particularly the other parameters, trace metals, pesticides, even the radioactive substance. But this is in a coming days, it will come. Right now, the Central Pollution Control Board is working on this. So generally, there are so many parameters. They have included the 42 parameters as far as the drinking water standards are concerned. But it is yet to be finalized, or for a gazette purpose, it is yet to be finalized. So this is regarding the water quality. When we talk about the drinking water, we have to be very, very specific. And for that, we have a WHO standard, BIA standard, ICMR standards. And based on that, we have to fulfill that. The source of the water, it should be fulfilled that. And ultimately, that water, we can utilize it for the purpose. Now, as we have seen, the water bodies, whatever we are considering. So in that, mainly we are diverting the wastewater. So here I am only commenting on the domestic wastewater. I am not commenting, or in my presentation, I have not included the industrial wastewater. So the domestic wastewater, whatever we consider, so, or you can say it is a sewage. So when it is entering into the water bodies, so the main problem we have, that is a eutrophication problem in our water bodies. And this eutrophication problem is because of the the wastewater treatment plant. Because in our wastewater treatment plant, we are not removing the nutrients. We are only removing the BOD and the solids. In a primary treatment, we are removing the solids, and in the secondary treatment, we are removing the organic matter, but nutrients are remaining as it is. And because of these nutrients, we will be having the eutrophications problem. So these eutrophications, whatever we are considering, so these eutrophications problem, so there are two things that we are considering. One, that is a eutrophication, and second one, that is nothing but it is a cultural eutrophications. Now, when particularly, what is the difference between eutrophications and the cultural eutrophications? So the very important thing is, generally the eutrophication problem will be a season specific. So you may have a problem, particularly the water bodies may have a problem in a particular seasons, then it is considered to be a eutrophication problem. And the cultural eutrophications problem, where the excessive growth of the nutrients, and because of the excessive growth of the algal blooms, and ultimately it is very, very difficult to control. So this is the problem where we consider this particular problem is a cultural eutrophication problem. In the next, you can see this is the slides where the water bodies, you can see the very good urban cities, but and the good water bodies, but the water bodies will be having a maximum eutrophications problem. So the very important thing is, right now majority of the Indian rivers, I think you have seen that we in a particular season or throughout the year, we may have a eutrophications problem. Even in a particular, it may be possible that not throughout the water bodies, but in a particular stretch of the river bed, we will be having this type of the problem. So this is the eutrophication problem, and these eutrophication problems, this is a very severe problem. Ultimately, this will leads to a problem on our water treatment plan. So the very important thing is we have to consider the eutrophications problem very, very effectively, and for that we have to consider some of the control measures. Otherwise this problem will be giving a problem to the other technical problems. Now this is the problem, this is only because of the agriculture activity. It is because of the agriculture activity, as well as it is because of the wastewater, whatever we are discharging into the water bodies. So ultimately the eutrophications, whatever we are considering, so that is because of the nutrients. Nutrients means in a wastewater, whenever we consider the ammonical nitrogen and the phosphate. Now whenever we consider the wastewater, from the wastewater, whatever we are generating into the residential area, so the ammonical nitrogen, that is because of the urea and the particularly the urine and all this. And the phosphate is because we are utilizing the varieties of the detergents, and generally the detergents and soaps that contains the phosphate. And mind well, our means the developing nations treatment plants are not designing for the removal of the nutrients. At the same time, generally the water bodies nearby, we will be having an agriculture activity. In an agriculture activity, we are utilizing more and more fertilizers, and ultimately because of that, we are from the runoff also we are getting nutrients into the water bodies. So generally, this is a very important problem right now the developing nations are facing, and at the same time developed countries are also facing. But the very important thing is developed nations, they have a very stringent rules and regulations, and they don't have to consider the political pressures. But in developing nations, generally, particularly the systems are more influenced by the political, and at the same time, we do not have a financial resources available, and because of that, we have to stuck up with if the solution is required. But I think we can, if anybody is interested, you can refer the history of China, because China have developed a very good problem, because in particularly this is the story of 1990 to 2010, where the majority of the China water bodies were facing the problem of eutrophications. But because of the stringent actions from 2012 to 2018, they have cleaned up majority of the river bodies very effectively. So to control that, you required the very important thing, and to control the nutrients is a very, very important task. If you want to clean that particular water bodies, it is a very, very difficult task. Only China can do it. We cannot do it. So the very important thing is we have to anyhow, the very important point is we have to stop the entry of the nutrients into the water bodies. And for that, we have mainly two things. Either you may go ahead with the tertiary treatment, and that is why generally I think you might be knowing, according to the new, already the draft policy has been already made by the Indian government, and according to this new policy 2020-2022, all the city has to go for the tertiary treatment, and once they will go for the tertiary treatment, the nutrients entry into the water body will be restricted. Now it is not like that we have also we have done nothing. We have also started doing lot of things as far as to control these all the things. And for that legislative aspect, we have a Water Act. We have some of the, particularly the National Water Policy, National Environmental Policies, and right now we have a National River Conservation Programs. At the same time, we have a National Lake Conservation Program, and right now GNURM missions. And according to these GNURM missions, each and every cities are getting a financial support to establish the STP. STP is what? This is a secondary treatment plant, as or the biological means, particularly the biological treatment unit. For development of that, they are getting the financial support. Now, generally, I think majority of the cities where we have a biological wastewater treatment unit for the removal of the BOD or the organic matter. So earlier we were following the trickling filter. This was the scenario where in 1980, where we were following the trickling filter for the removal of the BOD. Nowadays, after that we have followed the activated slurry process, and nowadays we are following the sequential batch reactor, because the sequential batch reactor, it requires less space, and it is nothing but it is a footprint of the activated slurry process. But then also we have not think for the nutrient removal. So nowadays it is the time where we have to think for the nutrient removal. So the very important thing is, either we may go ahead with the wastewater treatment, or we can when we have the tertiary treatment in which you have a specialized unit for the removal of the nutrients. So ultimately nutrients will be removed, and then you are diverting the wastewater into the water bodies. Or otherwise, where the tertiary treatment is not possible, you can have this type of the simple low cost treatment. So after the secondary treatment, so whatever the treatment plant we are having, after that particular treatment, we can have this type of the constructed wetland. It is nothing but, I think many of you are familiar with this. This is the particularly the, whenever the area is available, you can go ahead with this particular treatment option. And generally, whenever we have a wastewater treatment plant, majority of the wastewater treatment plant in urban areas where we are having, so we have a space available generally in a bank of the particularly river. So in that we can grow some of the specific plants, and these particular plant roots are absorbing the excessive nutrients, and they are growing with the help of these particular nutrients. So nutrients will be removed by the roots of the plants, and ultimately after that you can divert the wastewater again into the water bodies. So the nutrients will be removed by these particular plants. Now, the very important thing is, whatever I have discussed, the effect of point source and non-point source, and ultimately it is affecting the eutrophications of the water bodies. So that I will be discussing with the case study of the river Tapi. Many of you are familiar with the river Tapi, and this is the basin available in a Surat, particularly means it is the basin. So where we in the river where we have a Ukai Dam, and from the Ukai Dam at least 29 to 30 kilometers we have a Kakrapar Weir, and it is entering into the Surat city from the Kamraj river, and it will be having a 20-kilometer long stretch in a Tapi river. So as I have discussed the classification of the river as per the CPCB classification, throughout the year it is falling under the C category of the particularly the river, not in a B category of the river also. So C category means you can fetch the water for the drinking purpose, but that water you can use it after the treatment plant. So this is the particularly the river Tapi when it is entering through the particularly in a Surat city from the Kamraj from here, and ultimately when it is entering, you can see the Tapi river is considered to be a meandering river. So meandering means it will be having a means particularly this type of the particularly the slope in the stretch of the particularly the water bodies. So it is a very important meandering river of the particularly India. Now on this particular stretch of the Tapi, we have analyzed there are some of the point source available, and these point source are nothing but it is the wastewater which is at the treated or the partially treated wastewater of the Surat city. So that is entering into the particularly the Tapi River. Now, generally, right now, whatever we are discussing, so generally for these all the points, or generally the Surat Municipal Corporation have controlled it very effectively. So they have stopped as far as the all the point sources are concerned. So there is no particularly the illegal flow available from this particular source. So generally, whatever the source is, whatever the wastewater is entering, it is completely treated wastewater. And if you I think those who are from outside of the Surat, you can visit the Surat treatment plant, because all the treatment plant effective, they are working very effectively, and Surat is the Surat city is getting so many awards for that. So generally there are these are the water outlets from which the treated as well as untreated, where untreated wastewater is entering, because there are some of the reasons where the even urban authority has to allow the wastewater if there is no other alternative. So these are the particularly, or the other point source they have controlled very effectively. So the Sarthana and the Hanuman Tekri, so where there are the outlets, sometimes because of the unpredictable situation, they have to allow the untreated wastewater from this particular source. At the same time, particularly the Tapi River, where there are so many the small tributaries or the small khadis, so that they are joining with this particular river. So generally it is considered to be a khadi or the creek, so from which the wastewater is again entering into the water bodies. So generally the point source, whatever we are considering, we can say at least 90% of the water is available, and that is a treated wastewater, but the 10% water, it may be a untreated wastewater. Whereas the khadi, these are the source where ultimately we can, the prediction is very difficult, and we whenever we consider the situation, so generally we are considering that the 70 to 80% of the waterway is available, so that is untreated wastewater. So this is entering into the water bodies. At the same time, we on this particular stretch of the water, there are some of the non-point source, and these non-point source are nothing but it is the agriculture and the cattle farm available on the bank of the river Tapi. And this cattle farm, these are the big cattle farms, so where we can have the cattle, means 200 to 300 numbers of cows and buffaloes are available. So you can consider the discharge, whatever is available, so ultimately it is entering into the water bodies without treatment. So these point source and non-point source, these are very effective. Urban authorities are doing a lot of activities to control that, and they have effectively controlled the point source. But as I have discussed, these non-points, it is very difficult to control, because these are the cattle farms. So generally there are so many, even they won the they win the court the case in the high court, but the cattle farming people, they are not ready to leave that particular space. So it is very difficult to control that non-point source, and non-point source, they are also diverting the untreated wastewater and directly into the water bodies, and that is the wastewater which is having a very high nutrients value, because it is directly the wastewater from the wastewater with from the cattle farms. So generally on the stretch of the Tapi River, you can see that generally there are the 7 waterworks available, and that from this particular 7 waterworks, 1500 MLD waste the water Surat Municipal Corporation is getting, and they are supplying this particular water to the complete city. At the same time, in the water bodies, means there are 18 French well available, and these are the French well. Generally, it is managed by Surat Municipal Corporation, as well as some of the industries like SR, Kripco, and all. They have their own particular. So this Tapi River is satisfying the domestic demand of the Surat city as well as the industrial demand of the Surat city. But in some of the years, you can see, I think those means when you are the participants who are coming from towards the Ahmedabad side, when you are coming, you can see The Tapi river is nowadays, it is not a healthy river, but you can see this type of the green water hyacinth mat into the river. So this is nothing but the typical eutrophication problem. And this eutrophication problem is because of the entry of the wastewater from the cattle farm and the entry of the wastewater, the treated wastewater, and that is nothing but the nutrients, because as we have not removed the nutrients from the water body, from the wastewater. Now, in this particular water bodies, the green plants, whatever you can see, it is nothing but it is known as a macrophytes. It may be considered as a water hyacinth, or it may be considered as a jo Gujarati માં આપણે કહીએ તો એને જળકુંભી. So this is nothing but the aquatic plant. You can see with naked eyes very, very effectively. And there are two type of the plants. One is a submerged plant and second one that is a floating plants. So if you want to remove, it will be very, very difficult because the roots are spread in the riverbed in such a way that you are not able to remove it completely. Now the very important thing is why this particular macrophytes are grow in a Tapi river. So the very important thing is you require some of the favorable conditions, and these all favorable conditions is available in the Tapi river. So the first very important thing is the ambient temperature, that is about 25 degrees centigrade. Generally Surat city is having the temperature of in this particular range. Majority of the particularly the year, majority year days we will be having this. pH of the waste means particularly the wastewater, whenever it is entering into the water bodies, the pH of the river water will be in a category of this, it will be in the 6.2 to 7.4. There are so many, means because of earlier during the period of 1990 to 2000, there were so many unplanned, particularly the civil unplanned construction activity into the nearby water bodies, and because of that in some of the particular part the water becomes the stagnant, the river water becomes the stagnant. At the same time there is a erosion and sedimentation, and because of that also the water the river water becomes a stagnant. And the availability of the nutrients, as I have discussed, the availability of nutrients is from the cattle farm and it is from the untreated wastewater. These water hyacinths, so generally there are three important characteristics. They have a waxy leaves. Leaves are very waxy. They have a hairy roots and they have a spongy leaves. And because of this, one side, it is good also. So we can consider these as a nuisance because ultimately this will be nothing but it is a blockage of the water. The burden on the water treatment plant will be increasing from the intake structure, the roots of the plants, and it will clog the pumps and pipes, and because of that there will be a shortage of the water. So because there will be depletions of the oxygen level also, because these water bodies, these water plants also require dissolved oxygen for their growth. So because of that, even sometimes in some of the particular stretch of the river body, it may be possible that there will be anaerobic conditions, and because of this there will be economical burden on the authority or the Surat Municipal Corporation, because ultimately they have to remove this very effectively. If they are not able to remove it, then there will be a shortage of the water. So this is a very important thing. And the nutrients, whatever we are considering, because these are the green plants, this is nothing but these are like a green plants. They will grow in a water bodies, they will die in a water bodies, and that also generates the nutrients. When the plants are died, nutrients will be available again. So nutrients is already problem, and again that adds the excess nutrients into the water bodies. So this is a very serious problem. Generally we are not considering, we are not taking priorities on this, but this is very important issues right now. And the second very important thing, their growth is very, very fast. Their growth is very, very fast. It grows in acidic conditions also, it grows in alkaline condition also. So this will double in size within the 2 weeks. So the very important thing is how it will be affecting on the water bodies. So for that we have carried out a lot of studies, and right now we have one project with the Surat Municipal Corporations, and in that we have seen that when the growth of the macrophytes is maximum, when the growth of the water hyacinth is maximum into the river bodies. So ultimately it will be advantageous because that absorbs the BOD, organic matter. And because of that, you can see here in this particular plant, in this particular graph, this is at a particular locations where the growth is maximum. You can see the COD value will be going down. So the growth of the macrophytes, it helps one side. So organic matter, whatever we are considering, so the in a removal of this, water hyacinth plays a vital role. So one side it is advantageous, but the very important thing, it is not considered to be advantageous. Only for the removal of the organic matter, sometimes it is considered to be advantageous. Now, the very important thing is, whenever the second side is, whenever we can see the maximum growth of the macrophytes, you can see the ammonical nitrogen will be increasing drastically. This is a very dangerous level of the ammonical nitrogen. 5 milligram per liter is a very, very dangerous level, you can say, ammonical nitrogen. And when the growth of the macrophytes in the particularly water bodies will be maximum, the ammonical nitrogen concentration will be increasing. At the same time, you can see the MPN concentrations very high. But the very important thing is, when you are considering the water treatment plant, so we have considered the study of Randeer and the Katargam water treatment plant. So there are 7 water treatment plants are available, but these are the 2 treatment plants where the water bodies, where the treatment plants are very, very nearer to the water bank, means the river bank, and because of that, that affects the quality of the water. The growth of the macrophytes affects the quality of the water of this particular 2 treatment plant. Now here what is happening, once your ammonical nitrogen growth is increasing, at the same time kya hota hai, so ultimately this is increasing the TOC and the DOC level, total organic carbon and DOC, because you know ammonical nitrogen, so that is nothing but the nitrogenous organic matter. So because of that, your BOD, whatever we are considering carbonaceous organic matter, will be removed, but nitrogenous organic matter will not remove very effectively. Nutrients are remaining as it is. So the natural biodegradation process in which the carbonaceous organic matter will be decomposed, but the nitrogenous organic matter will remain as it is. So this is a very important situation, and because of that, the eutrophications will be considered a very, very dangerous stage as far as the water bodies are concerned. So generally, when we have considered the analysis, the Randeer and the Katargam water treatment plant, we have collected the sample, and in that we find out the TOC, total organic carbon, and DOC, dissolved organic carbon, very high, because the ammonical nitrogen and the nitrogenous organic matter, that increases the TOC and the DOC value of the particularly of the sample. Now you know this is our the conventional water treatment plant everywhere in India or everywhere in particularly world, we are utilizing this particular technology. But if the water is having a eutrophications problem, so ammonical nitrogen will not able to remove this particular water treatment. Your ammonical nitrogen will remain as it is. So mind well, these particular treatment plants are designed for the removal of the turbidity and the solids. So that will remove. But what about the ammonical nitrogen? Because of the eutrophication problem, already the ammonical nitrogen has risen. So these ammonical nitrogen will remain as it is in the water body. It will pass through the water treatment plant, but in the sample, whatever, or the particularly the water, whatever the ammonical nitrogen concentration at the inlet, it will remain as it is. So this particular our conventional water treatment plant are not able to remove the nutrients effectively. Now this problem, and at the same time, whenever there is a decay of the wastewater, the water hyacinth, so that develops a specific type of the chemicals like the humic acid and the fumic acid. And because of this ammonical nitrogen, humic acid, ultimately what is happening, these we have a, you know, all our water treatment plant, we have a disinfection system. So these ammonical nitrogen, humic acid, that will be reacting with the particularly the chloride, whatever we are utilizing for the disinfection purpose, and ultimately this chloride and TOC, DOC, humic acid compounds, that will develop the THM. This THM is nothing but it is a trihalomethane group of the compound, and these trihalomethane compounds are, it is a complex compound and it is considered to be a carcinogenic in nature. So these all are a carcinogenic in nature, and ultimately that will be creating a problem as far as the human health is concerned. If we are consuming the water which will be having a very high chlorine dose, it will be reacting with this, and ultimately it will be creating a carcinogenic effect to our body. Now, to control water hygiene, we have a lot of technology, but ultimately these all technology, because ultimately in a water bodies, whatever the chemicals you want to utilize it, so ultimately it is not good because it is not in a tank or in a reactor. Ultimately you are utilizing it for the complete volume, and that no one will be permitted. So there are some of the physical treatment available, chemical treatment available, biological treatment will be available, but these all treatments are not right now a safe treatment. So ultimately it's a very, very dangerous stage where the ammonical nitrogen that will be reacting with the TOC and DOCs and the formatting the trihalomethane groups. Now then also we have to think for the cleanup action. So one thing that the long-term plan in which we have to consider the cleaning of the Tapi river, and for that I think I'm happy to inform you all that the Surat Municipal Corporation is already getting a 600 crores rupees for the Tapi river Suddhikaran project, and urban authorities are trying to control all the point and non-point source. Whenever there is a non-point source, they are developing the STP so that the untreated water will not enter into the water bodies. But then also the very effective is the treatment plant. Now the conventional water treatment plant will not work for this particular technology because the ammonical nitrogen concentration will remain as it is in our conventional water treatment plant. So in a conventional treatment plant, in place of filter bags, the rapid sand filter, we have to go for the dual media filter or other options. So if we go ahead, then and then we are able to clean and control the pollution effect and control our THM only. So this is a very important things that we have to consider. Either we can have a complete cleaning of the river, or you can change the treatment plant. So where we have to change our rapids and filter only. So this is the only thing. Earlier we were utilizing the chlorine to control the pathogens, and that has created another problem of THM, trihalomethanes. So ultimately only the man is doing nothing but we are not able to control anything, or we are not able to completely control or reduce anything. Only we are able to convert from one phase of the pollutants to the another pollutions. So ultimately we all are connected, and ultimately that is why we have to think for all this particular problem very effectively. So thank you all, and if you are having any problem, you can take. You can ask me any
Thank you very much, ma'am. And there are 2-3 questions. We will quickly take it up. The first question is it ethical to use plants for cleaning wastewater in constructed wetland, since plants may undergo physiological stress due to harmful chemicals in wastewater? Plants also have life.
Actually, it is not like that. There are some of the plants. I think you have heard about the elephantia glass. So there are the particular species. That species only we can utilize. Not all the plants we can utilize. So the specific species, depending upon the climatic conditions, only we have to select.
Okay. The second question is, kindly throw some light on cultural eutrophication.
So actually, I think you have seen there are so many rivers and the water bodies where the complete, you will not get any blue color of the water, the complete green mat you will get it. So that is considered to be a cultural eutrophications, but it will be throughout the year. I think this is very common in pond and the lake, because generally pond and lake will be having a stagnant water. River, it may be possible that during the monsoon season you may have again a bluish water because of the dilution effect. So that is not considered to be a cultural eutrophications, but you have a pond or the lake where the complete green mat is available and throughout the year it will remain same. So then it is considered to be as a cultural pollution, cultural eutrophications.
Rina ma'am, you can ask.
Dr. Namrata, can you throw light what are the root cause for cultural eutrophication?
Actually, for a cultural eutrophication, the same conditions will be there, but For controlling, you don't do anything, but you just carry out, means only you are throwing the wastewater into the water bodies. You are doing nothing to reduce the pollutants. So in that type of the situation, slowly and slowly your water bodies will be converted. You will be having a cultural eutrophication problem. I think you are from Surat, you know, we have in a particularly the Tapi river, we have a eutrophication problem, but for that the SMC is continuously trying to remove it. So because of that, the Tapi river is not having right now the cultural eutrophication problem. But if we are not taking any actions, the day will come where we will be having a complete. It is considered to be as a cultural eutrophication problem.
So it is a long-term effect. You mean?
Yeah, it will be a long-term effect.
Okay. Okay. Thank you.
Ma'am, the next question is from Urvish Nagar. How to remove submerged microphytes from the lake? Because we can remove only floating microphytes with the weed cutter machine.
Actually, submerged macrophytes, it's very, very difficult to remove. And generally, for that, but in a particular stage, we have to go for the chemical treatment. Actually, the chemical treatment is not permitted. And that is why generally we are not doing that thing in a particularly the water bodies, because you know, generally suppose we have a something problem in our tank water, we can add something and we can make it clear. But it is a government property. Who will look after whether the chemical whatever we are adding, it is not having any other effects on health? So ultimately it is a very, very difficult task, and that's why right now particularly in a Tapi river also, we have a submerged macrophytes problem, but only they are taking the help of particularly manually only they are trying to remove it. In a particular day, hardly 1% they are able to remove it, but there is no other way.
I think you have answered his next question also. He has asked for that algae growth in lake, yellow water coming at the water treatment plant. Then what is the better solution for treatment?
Actually, there are two important things that you can do it. Already I have mentioned that particularly the algae, for that to control only nowadays the conventional water treatment plant, that we have to change it. So in that the filtration system that we have to change it.
Abhipsha, you can unmute and ask question.
Yes, ma'am. Actually, I wanted to ask that what is the reason for the carcinogenic effect? Matlab, how that water hyacinth chemical will come in contact with the chlorides?
No,
because chlorine we are adding after the treatment at water treatment plant. So it will be in that way, like
no, it is not like it that way. Actually, in a water, means in a water we have a ammonical nitrogen. So ammonical nitrogen, whatever is available in a water bodies, when we are getting the water in a water treatment plant from a intake well, okay, so it will remain as it is. There is no mechanism. The treatment plant, water treatment plant, is designed for the removal of the solids and the turbidity. So ammonical nitrogen, there is no unit where you are able to remove the ammonical nitrogen. So ammonical nitrogen will remain as it is. In a ammonical nitrogen, you have a humic acid and that type of the compounds. And ultimately that ammonical nitrogen and chlorine, these three will be reacting, and because of that THM group of the compounds will be developed.
Generated. Okay. Thank you so much.
It's not like that. Ammonical nitrogen is like a catalyst. So ammonical nitrogen, if we are able to remove it, then there will be no problem.
Okay. Thank you so much.
Thank you, ma'am. It's an informative, in-depth discussion on the topic. I really thank you for sparing your valuable time and highlighting the important aspect of pollutants for river water quality. So once again, thank you so much.
Thank you, sir.